Today's video helps us review Chapter 3. Chapter 3 is inequalities, and these will show up on your final. Question number 1, graph. Is this an open or closed circle? You're right, it's a closed circle. So what we need to do is first get a scale going on our coordinate plane. We know we have to graph -1, so let's put -1 in the middle. We have a lot of space here, so maybe we'll skip a space and put 0, skip a space and put -2. And we said this is going to be a closed circle. This symbol says x is greater than or equal to, so we want to shade numbers that are bigger, and then notice how they face the same direction as the arrowhead. Number 2, now we have to solve. So we need to get x by itself, so we're going to subtract 10. So I get 1 is greater than x. Remember, one of our rules is you always have to have the x in the front. So x and 1 need to switch spots. So if we switch spots, change our order, then we have to flip our sign. So 1 is the number we're concerned with, so we'll skip a space and put 2, skip a space and put 0, because we have a lot of room here. And this is an open circle, and we want to be less than 1. Number 3, write the inequality illustrated by the graph below. So the number in question is -2. And then we'll just use x. So we want all numbers that are bigger than -2. So bigger looks like this, but you cannot be -2 because this is an open circle, so I would leave my answer like that. Number 4, solve the inequality. So remember, we are envisioning a line going through our inequality that represents our equal sign. So we want to get x by itself. So we divide by -3. So we get x compared to +4. Remember, when you multiply or divide by a negative, you have to flip your sign. So our less than symbol becomes a greater than symbol. Number 5. Go ahead and put your lines through the inequality symbols. We want to balance our equations, get our x's together, get our numbers together. So I'm going to subtract 4, and I'm going to write it underneath the 3 because they are like terms, and I get a -3x is greater than or equal to x minus 1. And now I need to get my x's together, so I'm going to subtract x on both sides, because what I do to one side I have to do to the other, and I get -4x. So I've only subtracted things, so I don't have to flip my sign. But on the last step, I'm going to divide by a negative, so I have to flip my sign. And this becomes +1/4. So this reads x is less than or equal to 1/4. Pause the video at any time if you need more time. Number 6. We need to get the numbers on the same side, so we want to subtract a 5. So we get 2x is less than or equal to 6. Divide by 2. And now we have x by itself. 6 divided by 2 is 3, and we keep our inequality symbol. Number 7. Number 7 is a compound inequality, and I drew some lines through our inequality symbols. Let's review compound inequality. So a compound inequality is an inequality that is separated by either an and or an or. So if we were to look at this, we would say that if it's a bar, it would be an and. And if it's edges, this has got to be an or. So a compound inequality would look something like this, and an or would look something like that. So this would be what an and looks like, and this would be what an or looks like. An or has 2 parts, and an and has a strand, a big long strand. So now when I'm solving my inequality, this is compound, so is this an and or an or? This is an and. So I need to get x by itself. So I want to get rid of this minus 15. So I'm going to add it. And I have to add it to 3 parts, in the front, in the middle, and in the back. So I get 9, 3x, and 27. My inequalities do not change because I did not multiply or divide by a negative, and I did not switch my order. Now I need to get x by itself, so I'm going to divide by 3, and I have to do that 3 times. So I get 3, x, and 9, and my symbols stay the same. So my inequality is 3 is less than or equal to x is less than or equal to 9. So the numbers we need on our number line are 3 and 9. So maybe I'll start with 3 over here, 4, 5, 6, 7, 8, 9. And these are both going to be closed circles. So I'm closed at 3 and I'm closed at 9. And then I want to include all of the numbers that are in between 3 and 9. So this would be a bar. Let's try another compound inequality. This one has the word or in it, so this is an or. So when we graph it, we should have 2 sections of the graph shaded. We should have this edge and the other edge. So when we're solving it, we have 2 separate inequalities to solve. So let's do the first one. We want to get the x by itself, so we're going to add 2. So I get 3x is greater than 12. Divide by 3. X is greater than 4. Now we have a separate inequality, so I'm going to subtract 5, and I get a negative 2x, negative 6, and now I'm dividing by a negative. So then, negative divided by negative is positive, and I have to flip my sign. So, on our number line, we need a 3 and a 4. So maybe I'll put 3 here, I'll skip a bunch of space, put a 4 here. Are these open or closed? Open. And we want to be less than 3. And we want to be greater than 4. So our graph is edges. To prove that you watched the video, why don't you pick one of these images and try to duplicate it on your paper underneath number 8. So maybe put it somewhere in this area here. So what you want to do is pause the video, choose one of these, and just do a rough sketch so I know that you're watching the video. Number 9. Is the ordered pair 2, negative 4 a solution for the inequality? So remember, on a coordinate, this is really our x value and this is our y value. So we're going to plug those in here and here. So we get 2 times 2, so we just use this value and we put it in here, minus 4 times negative 4. So we took this number and we plugged it in here. And we're just trying to see, is this inequality true? So I get 4 minus times a minus is positive. 16 is greater than 20. So I get 20 is greater than 20. So is 20 greater than 20? No, it's equal to 20. So is this ordered pair a solution? I would say no, it is not. Why don't you try number 10 and 11 on your own? Please pause the video and I'll have the answers for you. Turn the video on after you're done with number 10 and 11. Number 10, we're going to subtract 1 from all 3 sides. And we don't have to switch our signs. 1 is an open circle, 1 will be a closed circle. Number 11, this is an and, so on our graph it should be a bar. Open circle at negative 5, closed circle at 7. Please draw a star under number 10 and 11 if you got it right. Here's a short video on absolute value in equations.
Now, the big, I guess, insight you need to have whenever you have an absolute value equation like this is just to remember, if I have the absolute value of A is equal to 11, what do we know about A? That means that A is either 11, that means that A is equal to 11, or what else could A be? Well, it could be negative 11. A could be equal to negative 11 because there's two possible A's that are exactly 11 away from 0. It could be positive 11 or it could be negative 11. That's the exact same logic you apply to an equation like this. If the absolute value of 2x minus 5 is equal to 11, that means that the stuff inside the absolute value sign either equals 11 or the stuff inside the absolute value sign is equal to negative 11. Because if this is equal to 11, the absolute value of 11 is 11. If this thing over here is equal to negative 11, when you take its absolute value, it'll still be equal to 11. So let's write that down. So 2x minus 5 could be equal to 11, or 2x minus 5 could be equal to negative 11.
And that would be how we're going to approach this problem. So we have the absolute value of x plus 4 is equal to 2. So we get two equations. X plus 4 is equal to 2, and x plus 4 is equal to negative 2. So you could have this answer, or you could have this answer. So what we're going to do is we're going to solve each one separately, and we get x is equal to negative 2, or x is equal to negative 6. So we have two separate answers. Don't you dare write those as a coordinate. Those are not coordinates. Those are two separate answers. So for absolute value inequalities, if it's a greater than symbol, it's going to be an or. If it's a less than symbol, it's going to be an and. So what we're going to do is copy the first inequality. This is a less than, so it's going to be an or. And we rewrite the other one as negative 4. So if we do a negative 4, then we have to flip our sign. And then you can solve each of those separately. I'm going to stop here. You pause the video and finish this problem. After you finish this problem, why don't you try setting up number 14 and then checking your answer with the video. The first thing I noticed is this is a less than, so that should be an and. Sorry about that. So then what we have to do is solve this, and we get this. And we know we can't leave our ands as two separate pieces, so I need to rewrite it. So I'm going to rewrite it like this, and they should always be less than symbols. Here is the setup for number 14. Please finish this up on your own.